So this is really cool. It's called a complex halo display, and there's a lot going on here. First up is that rainbow around the sun visible in this frame. That's called a 22-degree halo, and as the name suggests, the inner part of the halo always occurs at an angle of 22 degrees away from the sun. This is for a similar reason that rainbows occur at around 41 degrees, except here, instead of refracting through a rain droplet, the sun is refracting through a hexagonal plate ice crystal in the sky. Now, probably the reason why it's so much clearer in the lower half than in the upper half is that these 22-degree halos are much more likely to occur when the crystals are randomly oriented, rather than oriented with the hexagonal plate horizontally. To me, it looks like there are clouds that are lower in the sky, which suggests higher degrees of turbulence causing more random orientations, which would mean a brighter 22-degree halo. This is one of the 3-point reflections mentioned in the video, and they're called sundogs. These form for a similar reason as the 22-degree halo, except they form best when the ice crystals are oriented with their hexagonal plates horizontal. This makes sense in this context because the sundogs are just above the clouds, meaning less turbulence, and hence they are more likely to be oriented in their preferred aerodynamic fashion, plates horizontal. This faint spear of light is called a Helix Circle, and its dimness, even near the sun, is a consequence of the horizontal orientation of the ice crystals present in the sky. This type of halo phenomenon is primarily the result of reflections off of vertical faces of an ice crystal. Because these plates are likely mostly horizontal, their thin vertical edges result in a less distinct halo. In optimal conditions, a sharp Helix circle can be seen in an entire ring around the sky. Now this is perhaps the rarest phenomenon in this video. This thing here is a 46-degree halo. Now, it forms for a similar reason that a double rainbow forms in the rain, and it's closely related to the 22-degree halo. Now, the 46-degree halo is often confused for a superlateral or infralateral arc, but because the halo seems to pass straight through the Helix circle without cusping, while superlateral and infralateral arcs do not, it seems more likely. There are other ways to distinguish these, but because the sun appears to be at around 27 degrees above the horizon, and the halos are quite faint, it's otherwise hard to tell. Finally, we have, in my opinion, the coolest halo here, the Zenithal Arc. This is actually fairly common, but most people don't notice it because it's directly above their head. Again, these are caused by horizontal plate ice crystals. For these to form, light enters the top of the plate and exits through one of the vertical sides. Isn't this cool as hell?